Alright, in this video we're going to start talking about right triangle trigonometry and the trigonometric ratio. So it's going to be like a definition of all the trigonometric functions in terms of the sides of a right triangle. Now, if you've watched the videos that I've done previously on trigonometry, where I did a whole bunch of stuff about the unit circle and the definition of all the 6 trig functions in terms of the terminal points on the unit circle, hopefully you've seen all those and you understand all those definitions of the trig functions. Here we're going to be defining the same 6 trig functions, but in terms of a right triangle instead of in terms of the unit circle. But at the end of this video, I'll show you how the 2 different definitions coincide with each other. They don't contradict each other. They do mean the same thing, just in different context. Right? So before we get to the definitions of the 6 trig functions here, what the right triangle looks like. So we have a right triangle, right? Here's the right angle over here. That little square in the corner means that that's a right angle, a 90-degree angle. And here's our angle theta that we're talking about, right, over here. So I label the sides of my triangle in relation to this angle theta, right? The opposite side is if I go from this angle and I go to the side of the triangle that's across from that angle, right, I label that the opposite side of the triangle from my angle, right? So from this angle, this is the opposite side. The hypotenuse is the side that's always across from the right angle, right? So wherever my right angle is, if I go opposite of the right angle, or across from the right angle, we call that side of the triangle the hypotenuse, which might be a word that you remember from geometry. If you ever took a geometry class, probably you saw that word there. But the hypotenuse is always across from the right angle. And then the other side, right, the side that is next to this angle theta, we call the adjacent side. Right, so we always label the 3 sides of the triangle as hypotenuse, always across from the right angle. Opposite is across from the angle in question here, the theta. And then the adjacent side is the other one, the one that's next to the angle theta that we're talking about. All right, so understand what those mean, how to label the 3 sides. I've had students in the past get confused of which side to label opposite and which side to label adjacent. Remember, hypotenuse is always across from the right angle, so you can always label that one first. And then wherever your angle theta is, the angle in question, or the angle that you're dealing with, the side across from that is opposite, the side next to that is adjacent. All right, and now we define the 6 trigonometric functions as ratios of 2 of those sides of that triangle. Right, so the definition of sine of theta, right, again, if this is my angle theta, the angle that makes up that angle of the triangle, the sine of that angle theta is equal to the opposite side divided by the hypotenuse. Right, so if I take that ratio of those 2 sides, the opposite side, the length of the opposite side, over the length of the hypotenuse, that gives me the sine of that angle theta. Right, so that's the definition of the sine of an angle. Right, so sine is the opposite over the hypotenuse. The cosine of this angle theta is the adjacent side over the hypotenuse. Right, so if I want to find the cosine of this angle, the length of the adjacent side divided by the length of the hypotenuse, that gives me the cosine of that angle. The tangent of that angle theta is the opposite side over the adjacent side. Right, so tangent of this angle, I take the length of the opposite side over the length of the adjacent side. That's the tangent of this angle theta. Right, now those are the 3 main trigonometric functions, and there's a little mnemonic device that we use to remember that, and it's SOH CAH TOA. Right, so S-O-H, CAH, C-A-H, TOA, T-O-A. Right, so SOH means that the sine is the opposite O over the hypotenuse H. Right, CAH, C for cosine, is the A adjacent over the H hypotenuse. And then TOA, T for tangent, O for opposite, A for adjacent. Right, so sine is the opposite over the hypotenuse. CAH, cosine, is the adjacent over the hypotenuse. TOA, tangent, is the opposite over the adjacent. Right, so if you can remember SOH CAH TOA, right, that gives you the letters of how to set up these ratios for sine, cosine, and tangent. Right, and then as long as you're able to label the 3 sides of the triangle correctly, you can put together the ratios for those 3 trig functions. Now, if you have seen the other videos that I did about unit circle trigonometry and the definitions of the 6 trig functions in terms of the unit circle, you will recall that the other 3 trig functions, the cosecant, the secant, and the cotangent, are reciprocals of the first 3. Right, cosecant is the reciprocal of sine. So cosecant of theta, well, if sine is opposite over hypotenuse, for cosecant I flip that over, and cosecant of theta is hypotenuse over opposite. Right? Secant and cosine are reciprocals of each other. So if cosine is adjacent over hypotenuse, for secant of theta, I flip that over. Secant is hypotenuse over adjacent. And then tangent and cotangent are reciprocals of each other. So if tangent is opposite over adjacent, I flip that over, and cotangent is adjacent over opposite. Right? So if you know these first three from Sohcahtoa, right? So you use that to remember these first three, and then you remember the reciprocal relationships that I've talked about in other videos that I've done before. All you do is take those first three and flip them over, and you get the other three. Cosecant and sine, secant and cosine, cotangent and tangent. Those are the ones that are reciprocals of each other. All right, so that is the definition of the 6 trigonometric functions in terms of the 3 sides of a right triangle and the ratios of those sides. All right, so if you recall the definitions from the unit circle, you still need to know those definitions, like sine is the y coordinate, tangent is the y over the x, and so on. And now you also need to know these definitions in terms of right triangles. Right? When you're doing trigonometric problems, sometimes when you do trigonometry, it's dealing with triangles, and you can use these definitions to evaluate the trig functions and to solve problems. Sometimes when you're dealing with trigonometry, you're dealing with circles, and so you have to use like the unit circle definitions in order to work with the angles and to deal with the trig functions. So which of the definitions you use depends on the nature of the problem that you're doing, but you do need to be fluent in both of these different definitions, the unit circle definitions that I did in other videos previously, and now also with these right triangle definitions as well. All right, so I'm going to pause the recording here and then put up a picture where I show you that these definitions for the right triangle do coincide, and they do match up with the ones we talked about for the unit circle. They don't contradict each other. All right, so what I did here to kind of show you how the definitions we learned previously and the definitions we just talked about in terms of the right triangle, how they really do match up, is I put a right triangle into the unit circle, right, where the angle theta is in standard position, so the vertex of that angle is at the origin, and the initial side of that angle is on the positive x-axis, right? So if I draw that right triangle so that that upper point of the triangle touches a point on the unit circle, well, since the radius of the unit circle is 1, that makes the hypotenuse of that right triangle equal to 1. Right? So my hypotenuse here is 1, and the point where we hit the unit circle here, that point on the unit circle has an x and a y coordinate. And remember, previously, if you watch the other videos I did, we defined the trig functions in terms of the x and y coordinates of that terminal point up there, right? So let's see how that works here. So for these two sides of the triangle, like to get to this point up here, I go from the origin, I go over x units, right? So my adjacent side of the triangle here has a measure of x, right? However many units I go over here, that's the x coordinate of that point up there. Right? And then this side of the triangle is from the y-axis up to that point. So if the coordinate of that point is y, that's the length of this side of the triangle. The opposite side from my angle theta, the opposite side is going to have a length of y. Right? So again, if I'm plotting this point, I go over x, I go up y, those correspond to the x is the adjacent side of the triangle, the y is the opposite side. And the hypotenuse, since I'm dealing with the unit circle, that hypotenuse is a radius of the circle, right? It goes from the center of the circle out to the circle itself. And so, since the radius is 1, the hypotenuse of my right triangle is 1, right? So if I use the definitions, the ones we just talked about with the right triangle stuff, the sine of theta is the opposite over the hypotenuse. While the opposite side from my angle theta is y, the hypotenuse is 1. So I get that sine of theta equals y over 1, which means sine of theta equals y. Now, if you go back to the definitions we talked about in terms of the unit circle, the sine of the angle theta, or the sine of theta, is the y coordinate of that terminal point. Well, that's what this says. Sine of theta equals y. It's that y coordinate when I put that right triangle into the unit circle. Right? Cosine of theta is the adjacent side over the hypotenuse. My adjacent side is x, my hypotenuse is 1, and x over 1 equals x. Right? And if you think back to the definition of cosine in terms of the point on the unit circle, the cosine of theta is the x coordinate of that terminal point on the unit circle. So cosine theta equals x. Right? Tangent of theta, we just said, is the opposite side over the adjacent side. Well, for this angle theta, the opposite side is y, and the adjacent side is x. Right? So tangent of theta equals y over x, which that was the definition we saw for the unit circle, right? The tangent of theta is the y coordinate over the x coordinate, right? So the definitions we just talked about for the right triangle, the Sohcahtoa definitions is usually how I refer to them. they don't contradict the definitions we learned from the unit circle, where sine is the y-coordinate of your terminal point, cosine is the x-coordinate, tangent is the y over the x, and then of course the other ones are the reciprocals of all these. I won't go through the other three as well. Just seeing these three I think is enough, right? So when we put that right triangle into the unit circle and we force that hypotenuse to be a 1, the adjacent side is x, the opposite side is the y-coordinate of this terminal point up here, we see that those two definitions, opposite over hypotenuse, is y, right? Cosine, adjacent over hypotenuse, is x, right? Tangent, opposite over adjacent, is y over x, right? Those two definitions do match up, right? Just like everything else in mathematics, like nothing ever contradicts anything else, right? They might take different forms, but if you find a way to put them together, you'll see that they do match up, as we see here, right? So we have the two different definitions for the trig functions, the unit circle definitions in terms of the x and y coordinates of the terminal point, right? That's what we have over here in black. And we also now have the right triangle definitions in terms of the opposite, adjacent, hypotenuse sides of the triangle, right? Those are the ones that are up here in blue. And we can see that they match up, right? Sine is opposite over hypotenuse, but sine is also the y coordinate of your terminal point, right? So I just wanted to show you that so that you're not like, well, there's these two completely definitions for the sine function. Why are there two different definitions? Why aren't they the same thing, right? They are the same thing, right? But like I said previously, sometimes you do problems that refer to circles, in which case you need to use that definition that sine of theta equals y, right? The y coordinate of your terminal point on the circle. Other problems that you do deal with triangles, and you'll have to use a definition that sine of theta equals opposite over hypotenuse, right? They mean the same thing, as we can see from this picture here and what we did. They do mean the same thing. It's almost like the ones we learned previously for the unit circle are just one special case of the right triangle ones, right? If I do the right triangle, the hypotenuse of 1, then the right triangle definitions become the unit circle definitions, right? So they do match up. And you do have to know both of them. If you ever forget what they are, you can always do what we did here and kind of piece them together like we did here. It takes a little time to do that, but it works. So you need to know both of those definitions. You need to be able to switch from one to the other depending on the problem that you're doing. You need to know that sine is the y, but sine is also the opposite of the hypotenuse. Some problems you use this, some problems you use that. Now I'm going to stop this video here, and then I'm going to come back and do an example where we use these trig ratios, these new definitions of the trig functions, to actually do some work with a triangle and find the sine and cosine and tangent of an angle. So come back for that next video I'm going to do, and watch that one so you can see how we actually use this stuff to calculate and evaluate these trig functions for an angle.